Okay, this is a great problem, number 32, great question here. The region bounded by the x-axis in the part of the graph y equals cosine x between x equals 0 and x equals pi over 2. Okay, you don't have to graph this, but I'm just going to kind of explain it to you. So cosine x, well cosine x starts at 0, cosine is positive 1, and then at pi over 2 it's 0, right? So there's my graph for cosine x for from 0 to pi over 2. And it's divided into two regions by the line x equals c. Okay, so I'm dividing into this two regions at this point, x equals c. If the area of the region for 0 to c, from 0 to c of x equals, x is between 0 and c, is equal to the area of the region where x is between c and pi over 2, then c must be, what is it saying? Well, that's saying that the area of this region here is equal to this region here. Well, how do I find the area of the regions? I take the integral. So what is it saying? Well, this is my function, which is f of x equals cosine x, right? So I'm taking the integral of cosine x dx from 0 to c, and I'm saying that is equal to, right? The area of the first region is equal to the area of the second region. So the integral from 0 to c is equal to the integral from c to pi over 2 of cosine x dx. Right? Well, all we have to do is take our integrals. The integral of cosine x is sine x from 0 to c equals, this one here again is sine x, same integral, except this time it's c to pi over 2. So I evaluate these integrals. I've already got the equation here. This equals that. So now I just have to plug in for c, and then once I plug in for c, I should be able to get an answer for what c is. So I'm evaluating my integrals now, and I get sine of c minus sine of 0 equals, now evaluating this one, sine of pi over 2 minus sine of c. So the area of this region is equal to the area of this region, which means the integral from here to here is equal to the integral from here to here. Evaluate the integrals, then plug in for my boundaries. Okay, then I check, oh, sine of 0, that's just 0. Sine of pi over 2 is 1, right? So this becomes sine of c equals 1 minus sine of c. I add sine of c to both sides, and I get 2 sine c equals 1. Divide both sides by 2, because remember, I'm trying to solve for c, and I get what? Sine of c, kind of moving up here, sine of c equals 1/2. Okay, sine of c equals 1/2. Now my question is, alright, well obviously c has to be between 0 and pi over 2. What value for c do I get 1/2? What do I plug in? Well, if you remember our unit circle, the sine of pi over 6 is equal to 1/2. So therefore c equals pi over 6. Now, if you can't remember your unit circle, what you have to do is just say, if sine of c equals 1/2, then c equals the inverse sine of 1/2, okay? And your calculator will give you pi over 6. Now, the only thing is you have to be careful about just taking the inverse sine, because sometimes the domain isn't going to work out in your favor. So it's better to kind of just memorize and remember the unit circle to the best of your ability. But that being said, you can always default on this. A lot of times they use regions that you wouldn't run into a problem with the domain for an inverse trig function. But that's it. That's your answer, is pi over 6, which is B. So, hope you got it. See you on the next video.